Hello dear students, welcome to my YouTube channel Learn with YogeshSir. You are watching class 12th chemistry chapter explanation, and today in this video I will explain you chapter number 2 electrochemistry. This is the first part of this video. In the first part we will learn about electrochemical cell, and in the second part we will learn about electrolytic cell. So without wasting our time, let's start bachcho. So first of all, what is electrochemistry? So from its name you can see it is made of two words, electricity plus chemistry. So what does it mean? When chemistry meets electricity, or you can say when electricity meets chemistry. So it can happen in two directions. Direction one, some spontaneous chemical reaction produce electricity. It means chemical reaction help us to produce electricity, or it's vice versa. Direction two is when electricity forces non-spontaneous chemical reaction. For example, electrolysis, splitting water into hydrogen and oxygen. Why electrochemistry is important for us? All of you know that electrochemistry help us in battery, EVs, electroplating. Okay, not only in this, even it help us in corrosion prevention. If you know about corrosion, you can prevent it, you can stop it. It help us in metal extraction. Not only about the batteries, no devices, electrochemistry is in our body as well. Electrochemistry is not just in lab, it is inside you. Your body uses electrochemical process to transmit sensory signals. Cell communicate using electricity and chemistry continuously. Coming to electrochemical cell, what is galvanic cell? You have heard about it, you have studied about it in class 11th. The galvanic cell converts chemical energy from a spontaneous reaction into electrical energy. For example, the Daniel cell where we use zinc rod and copper rod and their solution to produce electricity. Let's learn about this in detail. So you can see here the picture of Daniel cell. You can see there are two solutions. On the left side there is zinc sulfate, on the right side there is copper sulfate. In the zinc sulfate, zinc rod is there. In the copper sulfate, there is copper rod. So what is going on here? So this is the cell notation. We can show a cell. So this is the left side anode part, this is the right side cathode part. Okay, so what is going on anode side? On the anode side, oxidation is going on. What is oxidation? You have already learned about this in class 11th. Oxidation means when some element, some metal, some compound lose electron. For example, here zinc is losing 2 electron and it is making zinc 2 plus ion. Okay, and on the other hand, copper ion is gaining electron, and gaining of electron is called reduction. At the cathode side, reduction is going on. So this is the cell notation of Daniel cell. These are some key features. There are two half cells. There is a salt bridge that maintain electricity neutrality. In the salt bridge there is potassium chloride which maintain the neutrality. Electron flow from anode to cathode. Electron is flowing from zinc to copper. Zinc is anode, copper is cathode. So electron is going from left to right, and current is flowing from cathode to anode. That is called conventional current. So this cell convert chemical energy into electric energy. EMF of the Daniel cell is 1.10 under standard condition. What are the standard conditions? Standard condition means temperature is 25 degrees Celsius, air pressure is 1 atmospheric pressure, and the concentration of both solution is 1 mole. Okay, so these are the standard condition, and this standard condition EMF of this Daniel cell is 1.10 volt. So when we add some external battery here, some external cell here, what happens here? So let's see. There are three scenario. First scenario, as all of you know that in standard condition the EMF of the cell is 1.10 volt. As we add an external battery here, and the voltage of that battery is less than the voltage of the Daniel cell, obviously the current will keep flowing in the same direction, because the external battery current is not enough to oppose the Daniel cell current. In the scenario 2, when the current of the power of the battery is the same as of Daniel cell, so in this case no current will flow because the power of both Daniel cell and the battery, they are opposing each other and it is neutralizing. In the scenario 3, when the voltage of the power of battery is more than the power of Daniel cell, like here you can see the voltage of battery is 1.3 volts. So in this case what will happen? In this case current will flow in the opposite direction, or you can say cathode to anode. So anode versus cathode. You already know about this. Oxidation happens at anode. Okay, and negative you can show it by negative charge. Electron leave the anode. Anode is in the negative terminal. On the other side, reduction happens at the cathode, and we show it by positive sign. Electron arrive at cathode. Current flow from cathode to anode, that is called conventional current. Electron flow from anode to cathode. How to calculate cell EMF? EMF means electromotive force. So how to calculate? The potential difference between electrode is the cell potential. So if you want to calculate what is the total power of the cell, it means what is the total EMF of the cell, we need to calculate the difference between the two electrodes. Okay, so in this way, by comparing their difference, we can find the EMF of the cell. When no current is drawn, it is called EMF. So how to calculate EMF? So there is a formula: electrode potential of the right side minus electrode potential of the left side. Example, you can see copper, silver, galvanic cell. So this is the notation of the cell. And a classic galvanic cell setup, a digital voltmeter above the cell reads the voltage. So in by the comparing the potential difference of both electrode, we can find the electrode EMF of the cell. But there is a problem. What is this? We cannot measure the potential of just one half cell. You cannot measure the potential of zinc electrode only. You cannot measure the potential of copper electrode only. To find their potential, we need a reference electrode. So in this case, we take help of hydrogen electrode. What is this? This is called standard hydrogen electrode. What is a standard hydrogen electrode? The SH is set at exactly 0.0 volt. Our ultimate baseline consists of an inert platinum. You can see there is a platinum rod in this. So there is a question how to determine the electrode potential of magnesium. So here we use standard hydrogen electrode as a reference electrode. So this is the setup of the cell. Connect a magnesium electrode to the standard hydrogen electrode under standard condition. You must know what are the standard conditions. Standard condition means temperature 25 degree, atmospheric pressure 1 bar 1 atm, and the concentration of both ion must be 1 mole. So here you can see this is the setup cell diagram. Which electrode is cathode? So this is very important. We have to find which electrode is working at as cathode. Cathode means where reduction is going on. So you can see magnesium. This is the reduction reaction of magnesium. This is the reduction reaction of hydrogen. But you know that magnesium is highly reactive. So highly reactive means it can lose electron easily. So magnesium here will be oxidized easily, and if it is oxidizing easily, so where is reduction going on? Reduction is going on standard hydrogen electrode side. So therefore SHE will be reduced and act as cathode. So you know the formula to find the EMF of the cell at standard condition. It is E naught cell is equal to E naught of cathode minus E naught of anode. And when you will measure the voltage of the cell, you will find it is 2.37 volt. So keep this in this formula. E naught of cathode is 0 because that is standard hydrogen electrode. So using this, standard electrode potential of magnesium. You have to take care of this thing. More reactive metal oxidize easily, so they will work as anode. The less reactive metal, they will be reduced, like here in this case it is hydrogen when we compare with magnesium, so that will act as cathode. So this is the standard reduction potential table. Using this table, you can easily find which which electrode will work as anode and which electrode will work as cathode. So you have to just compare their standard electrode potential. For example, taking example of sodium and bromine. So if we have one rod of sodium and the other rod of bromine, so in this case you can see reduction potential of bromine is far more than sodium. So obviously bromine will work as cathode. Reduction will happen here, and on the other side oxidation will be there. So in this way you can compare easily which will work as cathode and which will work as anode. So I told you that to find the standard electrode potential of any rod, we use hydrogen, the standard half cell on the other side. But why hydrogen only? In electrochemistry, we need a reference cell. I told you we need a reference cell to start something. To start counting, we need zero. We have to start from somewhere. So we use hydrogen. But why hydrogen only? There are some favorable condition for hydrogen. So first one is hydrogen is the natural dividing line. So you can see here some element are more reactive element are on the left side, more less reactive element are on the right side. Okay. So you can easily see hydrogen is lying just be in the middle. So that is the one favorable condition for hydrogen to make him standard hydrogen electrode. So the second one is solid metal are actually messy. What does it mean? While a solid block of copper zinc is easy to hold, a solid rod it's very easy to hold. If, it doesn't matter it is of zinc, of copper or magnesium. Then why we are taking hydrogen as a gas when it is not easy to handle? If a scientist in London and a scientist in Mizoram both use a standard copper electrode as a reference, they might get slightly different voltage reading. Why it will happen? Due to oxidation. Copper develops a microscopic oxide layer in the air that is called zinc corrodes. So obviously if corrosion is going on, it will give a different reading for voltage. Okay. Second one is impurity. If we are dealing with some solid or liquid, there can be possibility of having impurities. But if you are dealing with gas, there will be less chance of impurity. The third one is surface condition. Solid have microscopic scratches, polishing, or any surface contamination can change the potential. But in case of gas, there is no such problem. Okay, there are so many drawbacks of SHE. So is there any other option? Yes, there is the option. Chemists use solid easy safe reference electrode. What is that? That is silver chloride. Okay. And why they use silver chloride? Because it is made of silver wire coated with silver chloride placed in a solution of potassium chloride. Cheap, solid, easy to store and use, safe and reliable. So instead of using the difficult SHE, we use easy silver chloride electrode and convert the reading to the hydrogen scale. Why does the voltage of a battery change? Okay, like if you are buying a new battery of having voltage 1.5, after using it for several weeks, it still give 1.5 volt? Obviously no. The question is, why does the voltage decrease with the time? Its answer is, as the battery works, reactants are consumed, products are formed. You know that like in Daniel cell there is zinc rod, there is copper rod, there are solution of zinc sulfate, there is solution of zinc sulfate, there is solution of copper sulfate, and the reaction is going on. Zinc rod is dissolving into zinc sulfate. Copper from the copper solution they are collecting at copper rod. So reactants are changing into products. Since the chemical condition change, the cell potential also change. We need a mathematical equation that tells us how the cell potential changes under real condition, and the equation is called Nernst equation. And the Nernst equation is developed by Walter Nernst, that is a that was a German physical chemist, and he won Nobel Prize in chemistry in 1920 for his work in physical chemistry. So in 1889 he showed that chemical energy can be converted into electric energy, can be related mathematically. So using Gibbs free energy, he derived Nernst equation Okay, so this is the general equation. Okay, E means here electrode potential at any temperature. Okay, and E naught means standard electrode potential, which we already know. I show you the table. Okay, so we know E naught for all of the, for most of the elements. We know E naught for most of the elements, so we have to find E at any, at a particular temperature, at a particular pressure. So this is the equation: E is equal to E naught minus 2.303 into R into 2 R into T divided by N into F log Q. So what is R here? R is gas constant. You already know about it. T is temperature. Where the room temperature, what is the room temperature? F is Faraday constant. F is Faraday constant. What is Faraday constant? Faraday constant is the amount of charge carried by 1 mole of electron. Okay, you know what is 1 mole. N is the number of electron transferred. Like in case of Daniel, it is 2. Daniel cell, it is 2. Okay. When you put the values of R, that is gas constant 8.314, Faraday constant 96485, you will get a simplified equation, that is at and if you are putting temperature 25, so you will get E is equal to E naught minus 0.0591 divided by N log Q. And what is Q? Let's see. These are the terms I told you. N is the number of electron transferred. Q is the reaction quotient. Reaction quotient means ratio of products and reactants. Okay, so coming back to the Daniel cell, so here you can see Q is equal to zinc ion divided by copper ion. Okay, why zinc is at numerator and copper is at denominator? Because zinc is product, zinc electrode is changing into zinc ion. On the other side, in Daniel cell, copper ion is changing into copper, so copper is reactant and zinc ion is product. If zinc ion zinc ion concentration will increase, value of Q will increase. And if the value of Q will increase here, if the value of Q will increase, so this will also increase this portion, and finally electrode potential will decrease. And on the other hand, its opposite side, if copper concentration is increasing, or you can say copper concentration is more than the concentration of zinc, so in this case value of Q will decrease, and if the value of Q will decrease, electrode potential will increase. So, or you can simply say more products, lower voltage. If the products are more, the voltage will be low. If the reactants are more, voltage will be high. So this is all about for today's video. Thank you. See you in the next video.